In this screencast, we are going to talk about factoring quadratics. So first off, you may be thinking, what is a quadratic? So a quadratic is when the exponent is the highest power of a 2. So like, for example, x squared would be a quadratic. So all of these problems that we're going to do, the highest exponent is a 2. So what we're going to do for problem 1, first of all, factor means to break down. So we are going to take what we have, which is called a trinomial, and I know I'm throwing a lot of vocab at you, and just means that there's 3 parts. So tri means 3. So first thing we're going to do is we are going to make ourselves a rectangle or a box, and we're going to make ourselves a diamond. I'm just going to make mine one big X. And what we're going to do with this is the same process over and over again. So it is very systematic. If, once you get it, you get it. Excuse me. So what we're going to do is we're going to start with that first term, which is x squared. That is always, always, always going to go in the top left corner every single time. So first term, x squared, goes in the top left corner. The last term, the constant, the number that has no variable, the 12, is going to go in the bottom right-hand corner. It's a positive 12, so we can add a plus sign, or you can just leave it as 12. So this is the first step. So first term, top left. Last term, bottom right. From here, what we're going to do is we are going to take the 2 pieces that we have here, and we're going to multiply them together, and that becomes the top of the diamond. So we have 12 times x squared, which becomes 12x squared. So those 2 get multiplied, and they go on the top of the diamond. The middle term, which we've done nothing with as of right now, try to change that color. We're going to make it pink. This 7x is going to go in the bottom of the diamond. So this is the same process for every single problem. I know right now it looks very confusing because there's arrows everywhere, but trust me, once we do several of these, it becomes like second nature, and it's kind of like a puzzle. You might find it to be fun. So what happens is now we have this diamond problem, which we just talked about diamond problems this past week. So we need 2 numbers that multiply to get the top, which is 12x squared, and add to get the bottom, which is 7x. So we know right now that both of those numbers have to have an x for that to work out. So we need to think what 2 numbers multiply to give us 12, but add to give us 7, and we'll end up with 3x and 4x. Now, these 3x and 4x could be flip-flopped, so that does not matter. And then what we're going to do is we're going to plug them back into our rectangle. So I, for some reason, cannot erase on here things that I've done. I don't think I can. No, it won't let me. So I think I'm going to just remake my rectangle over here, just so I don't have so many arrows going on. So we have x squared, and we have the 12. So what happens is we're going to plug in our 3x in one of the empty spaces and our 4x in another empty space. So again, this was way too confusing and looking to me, so I thought I'd just make it a little clearer by redoing it over here. So when we go to do this process, you are basically trying to find what is going to be on the outside parts. So we want to find out what's going to go in our parentheses, so if we multiply these 2 things together, it gives us x squared plus 7x plus 12. So to start, we are going to put an x at the bottom of that first row and at the top of the first column. So checking x here and x here make x squared. So that works out. That's perfect. Let me erase that there. Oops, did not want to erase the x, sorry. This is still an x. All right, now we're kind of working backwards. We want to figure out, all right, what's going to go here? So when we multiply with x, we get 3x. Well, 3 times x will give us 3x. So we are going to put a 3 out front. And then down here, we need to figure out, okay, what times 3 gives us 12? Well, that's going to be a 4, because 3 times 4 is 12. So let me erase this arrow. So that's going to become a 4. So when we're done, we have an x plus 3, because that 3 is positive, and then on the bottom we have an x plus 4. So if you wanted to check to make sure this is right, you could multiply them back together. You could do the FOIL method. Remember, there's a couple of different ways to do it, but it should equal out to x squared plus 7x plus 12. So we're taking the trinomial in the beginning, the three-parter, and we're breaking it down to the two parentheses. All right, let's look at problem 2. We have 2x squared plus 7x plus 6. Again, this is a quadratic because the highest exponent is a squared. So we are going to start with the same process we did the first problem. Again, this is the same process for every single problem. The first term always goes in the top left corner. So 2x squared, put that there. The last term, 6, positive 6, is going to go in the bottom right corner. So what we're going to do from here is now we're going to fill in the diamond. We're going to multiply these two pieces of the rectangle together. So 2x squared and 6 make 12x squared. So that goes on the top of the diamond. And then the bottom of the diamond, we're going to have a 7x. So I realize this is the same problem, but it's slightly different. So what we're going to do is we want to figure out, okay, what times what gives us 12x squared, but as give us 7x. So we know there's both x's here. And then we can try our different numbers, and we're going to get 3x and 4x. So plugging them back in to our empty spaces, we need to figure out now what's going to go on the top and the bottom and the side, which is going to be in our parentheses. So like I said in the previous example, I would automatically set up your x's on the outside there, because no matter what, this x and this x are going to make that x squared. So you're going to have that regardless. So it's always a good idea to start there first. So what we're looking at next is, okay, x and x don't make 2x squared. It makes x squared, but not 2x squared. So we kind of need to use our GCF and figure out what do things have in common. So I always look at my first column there. So we have a 2 and a 3. 2 and 3 have no other number besides 1 in common. So that's going to be a 1x. So if I work backwards, what number times 1 is going to give me my 2? Well, that's going to be the number 2. So let me erase that x there. So this is going to become a 2. So if we check, x squared and 2x make 2x squared. Coming down here, we need a number times 1x to get 3x. Well, 3 times 1x will give us 3x, so this becomes a 3. Down here, 3 times what gives us 6? Well, 3 times 2 gives us 6, so that's going to end up being a 2. So when this is all said and done, our factored form will have 2x plus 3. So that's here, and it's a plus because it's a positive. And then in our second parentheses, we'll have 1x or x plus 2. And again, that's coming from here. So we're taking what we know, our trinomial, and we are breaking it down. Factoring means to break down. Okay, problem 3, 2x squared plus 5x plus 3. So I find that repetition really helps with this, so we're going to be doing 9 examples here. So this is problem 3. So first term, again, always goes in the top left corner every single time. The last term, which is positive 3, is going to go in the bottom right corner. We're going to multiply those two together to get 6x squared, which is going to go on the top of the diamond. And then 5x is going to go on the bottom. So remember that middle term always goes on the bottom of the diamond. So now we have a diamond problem. where we need two numbers that multiply to give us 6x squared, but add to give us 5x. So you can think about what multiplies to give you 6, and which of those would add to give you 5. So we're left with a 2x and a 3x. We're going to plug them in. Again, order doesn't matter, so you could have these reversed. And then we're going to fill out the outside. Automatically, I'm going to put those x's, outside, because that is going to be in the problem no matter what. So, looking at our first column, besides an x in common, we have a 2 and a 2. Well, 2 and 2 have a 2 in common. So the greatest common factor out here is going to be a 2. So working backwards, we need to figure out, all right, what here times 2x is going to give us 2x? Well, we're going to need a 1 out there. So 1 times 2x is 2x. If we check the top, 2x and x give us 2x squared, so that's good to go. And then the last part, we need to figure out, okay, what's going to go here? What times 1 is going to give us 3? Well, that's going to end up being a 3. So this becomes 3, and then we'll have our parentheses. Our side here is x plus 1, and then the bottom is going to be 2x plus 3. Again, order doesn't matter. You could have these parentheses flip-flopped. You could write 2x plus 3 first and x plus 1 second. All right, looking at example 4, 3x squared plus 10x plus 8. So again, first term, 3x squared, is going to go in the top left corner. The last term, which is 8, is going to go in the bottom right corner. We're going to multiply them together to get 24x squared. Middle term, 10x, is going to go in the bottom of the diamond. So we need two numbers that multiply to give us 24x squared, but add to give us 10x. So we know they both have x's, okay? So we need two numbers that multiply to give us 24, but add to give us 10. So you can think of all your different options. If you're having a hard time thinking about your options, make a list. I find that is helpful. So 24, we could do 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So of my list, if these are all positive, I'm going to have to go with the 4 and the 6x, because they're going to add to give us 10x. So I'm going to plug them into my empty spots, and I'm going to put my x's out on the outside, and then I'm going to look to see what they have in common. So if I look at this first column, I have a 3 and a 4. 3 and 4 have nothing besides a 1 in common. So that number out front of our x is going to be a 1, or you could drop the 1 and just leave it as an x. So looking here at the top side, what times 1x, or excuse me, x, sorry, I'm getting myself confused. If you have a 1x, so 1 times what will give you 3. So we already have our x's taken care of, so we're not going to worry about the x. So if we think about it, 1 times 3 is going to give us a 3. So we have a 3x, 1x makes 3x squared. Okay, so now we're looking at this part right here. We need something times 1x to give us 4x. Well, that's going to be a 4. And then down below is going to end up being a 2, because 2 times 4 will give us 8. So our parentheses is going to be 3x plus 4, and then we'll have 1x plus 2. So again, we are factoring, we're breaking down the trinomial, the three-parter, into two parentheses. And you can always check by multiplying these two parentheses back together. All right, so problem 5, same setup as before. So 8x squared goes in the top left corner, positive 3 goes in the bottom right. We're multiplying them to get the top of the diamond. But now notice that there is a negative, which is okay. It just means that 10x is going to be negative. So in our diamond problem, we need two numbers that multiply to give us 24x squared, but add to give us negative 10x. So we know there's going to be x's. And if we think about the last problem, we made a list of everything that multiplies to give us 24. So I'm going to have that same list written up here. Now, we need them to multiply to give us 24, positive 24, but add to give us negative 10, which means both numbers have to be negative. So if we take a look at our options, that kind of eliminates everything except our negative 4x and our negative 6x. So we're going to plug them back in. Again, order does not matter. We're going to pull out our x's, and then we want to go from there. So if we take a look at that first column, we have an 8 and a negative 4. So 8 and negative 4, so we're going to ignore the negative right now. But 8 and 4, you want to find their GCF, so their greatest common factor. So yes, you could say, oh, they both can be divided by 2, which is correct. But we want to pick the highest number that can go into both of them. So we're going to pull out a 4x. So up top here, 4 times what will give us 8? So that's going to give us a 2 out front in front of this x. So 2x and 4x make 8x squared. All right, now looking at this side, we need something times 4x to get negative 4x. So now we're going to throw in our negative sign. So this is going to become our negative 1. So you can check 4x times negative 1 is negative 4x. All right, and then the last part, we need a number times negative 1 to give us positive 3. So what you could do is you could take 3 and divide it by negative 1, or you could work backwards and think, okay, what number times negative 1 is positive 3? But that's going to end up being a negative 3. So negative 1 times negative 3 will give us a positive 3. So our parentheses will have 2x minus 1. Okay, minus because now is that negative, and then 4x minus 3. So we really want to watch your signs. If it's not all addition in the beginning, if there's a minus sign, there's going to be a minus sign in your answer. All right, looking at problem 6. Again, we have a negative in there, so one of our answers, or maybe two of them, are going to have negatives. So we're going to start with the same process. X squared goes in the top left corner. Negative 24, because that 24 is a negative, it's going to go in the bottom right. We're going to multiply them together to get the top of the diamond. And then the middle, 2x, becomes the bottom of the diamond. So we need two numbers that multiply to give us negative 24, x squared, but now add to give us a positive 2, x. So again, we're kind of dealing with the same numbers here. So I'm just going to make my list of my numbers that multiply to give me 24. Now, we need them to multiply to give me negative 24, but add to give me 2. So that means that the smallest number of the two has to be the negative, so that when we add them, that number becomes a positive 2x. So taking a look at our options, we can eliminate the first one, and negative 2 and 12 don't give us 2. 8 minus 3 doesn't work. So we're left with negative 4x. So negative 4x and positive 6x. So I'm going to plug them back in. Again, order does not matter. And I'm going to automatically pull out my x's that are going to be on the bottom and the side. So x and x make x squared, so that's good to go. So now we're looking at, okay, what number times x gives me negative 4x? So that is going to end up being a negative 4. Again, we have to be careful of our signs. So then the last missing piece, we need what number times negative 4 gives me negative 24. So that's going to turn out to be a negative 6. So again, if you check, I'm sorry, not a negative 6, a positive 6. Good thing I checked my mind there. So if you check it, 6 and negative 4 make negative 24, and then 6 and x make 6x. So we are left with x minus 4, and then x plus 6. So again, the sign is from what happens in the problem. So here, this x, and that's a positive 6, that's why it's a plus. This x minus 4, it's a negative 4, that's why it's a minus. Alright, for problem 7, same setup. First term goes in the top left corner. Last term, or 25, goes in the bottom right. We're going to multiply those two pieces together to get the top of the diamond. Now, the middle piece, negative 10x, is going to go on the bottom, and the negative goes with it. So we need two numbers that multiply to give us 25x squared, but add to give us negative 10x. Now, we know that they're both going to have x's. I think we've kind of gotten to that point that we understand that. And now we need to think about what multiplies to give us 25. So again, I'm going to make myself a list over here just because that helps me. So we have 1 and 25 make 25. We have 5 and 5. And that is it. So looking at our choices, we need two numbers that multiply to give us positive, but add to give us negative. So that means both of these numbers have to be negatives. So the winner here is going to end up being negative 5x and negative 5x. So we're going to plug them back in. We know that there's an x on the outside pieces there. And now we want to fill in the rest. Well, x and x make x squared, so that's fine. We don't need to touch those anymore. So down here, we need something times x to get negative 5x. Well, that's going to end up being a negative 5. And then down here, we need something times negative 5 to get 25. So you could either take 25 and divide it by negative 5 to get negative 5, or you could just kind of figure out that's going to be negative 5. So this ends up being x minus 5 and x minus 5. Sometimes you may see this also as x minus 5, the whole thing squared. These are saying the same thing. So if you have the same parenthesis 2 times, we can say that that is squared. Alright, problem 8. 5x squared minus 4x minus 1. So same process as before. We're going to start with the top left corner, which is the first term, which is 5x squared. Negative 1 is the last term, so it's going to go in the bottom right. We're going to multiply them together and get negative 5x squared for the top of the diamond. The bottom becomes negative 4x. So we know that there's two numbers that need to multiply to give us negative 5, but add to give us negative 4. Well, there are only two numbers that multiply to give us 5, and that's 1 and 5. There are no other numbers, and we will only use whole numbers for these. So now we have to figure out which one is going to be negative. So we want them to multiply to be negative, but then add to be negative. So that means our 5 is going to have to be the negative number. So we're going to plug in the two that we have into our empty spaces, fill in those x's, and now we want to go from here. So looking at the first column, 5 and 1 have only a 1 in common. So their GCF is 1, so we're going to pull that 1 out, or you could just leave it as an x. So then looking up here, we need a number times 1 to give us 5. Well, that's going to be 5. So this is a 5. If we take a look down here, we need something times 1x to give us 1x. So that's going to be a 1. And then down here, we need something times 1 to give us negative 1. So you can always take negative 1 and divide it by 1, and you'll end up with negative 1. So our parentheses will have 5x plus 1, and then x, or 1x, minus 1. And again, order doesn't matter. You could have these two parentheses flip-flopped. Yay, we made it to problem 9. So this problem looks slightly different, but it is the same process. So first of all, you have a 9x squared, and you have that negative 1, the constant. So first thing I'm going to do is I'm going to rewrite my problem, and I'm missing my middle term, my x term, so I'm just going to plug in a 0. It is the same problem, it's just we're now putting in a 0x kind of as a placeholder. Now we're going to set it up same way. First term goes in the top left, last term goes in the bottom right, multiply them to get the top of the diamond, and now 0x is going to go in the bottom of the diamond. So we need two numbers that multiply to give us negative 9x squared, but add to give us 0. So if we think about our options, we have 1 times 9 and we have 3 times 3. Those are only two choices. Now, for it to multiply to give us a negative 9 but add to give us 0, one of them's got to be a negative and the other one's got to be a positive. So if we take a look at our choices, the 1 and 9 don't work, but negative 3 and 3 will. So we're going to plug them in. Again, automatically I'm going to set up my x's on the outside. And now I'm going to look at my numbers, find my GCF. I have a 9 and a negative 3. Again, not worrying about the negative sign right now. But 9 and 3, their GCF is a 3. A 3 can go into both of them evenly, the highest number. So knowing that, I need to figure out, okay, what's going to go up here with my x. So a 3 times what will give me 9? Well, that ends up being 3. So 3x and 3x make 9x squared. Down here, I need something times 3x to give me negative 3x. So that's going to turn out to be a negative 1. And then down here, something times negative 1 gives me negative 1. Will end up just being the number 1. So for our final quadratic here, we will end up having 3x minus 1 and 3x plus 1. And if you're not sure, again, if you go back and check, when you multiply these together, these two middle terms are going to cancel each other out. That's where that 0x is coming from. I know this is a lot, but again, repetition is very helpful with these factoring problems.